Okay, ladies and gentlemen, we are discussing how to solve a quadratic equation by graphing, quadratic equation by graphing. The solutions for any quadratic equation in the form ax squared plus bx plus c equals 0 are the x-intercepts of the related quadratic function f of x equals ax squared plus bx plus c. Now please notice that there's 3 other blanks on this page. That's because x-intercepts is a math term that is interchangeable with the word solution. So solutions would also fit in one of those blanks. It is also interchangeable with the word roots and the word zeros. It doesn't matter which of those words is included in the directions for your problem. If it asks you to find the x-intercepts, the solutions, the roots, or the zeros, it's asking you to do the same thing. It's asking you to discover where the graph of that function crosses the x-axis. So essentially this is going to turn into a 2-step process overall, one step of which is going to require more work from us than normal, and that is that we are going to graph the related quadratic function Again, that's going to be in the form f of x equals ax squared plus bx plus c. And then we are going to state the x-intercepts. So, let's do some examples. Here we have, before we get to the examples, that means we have basically 3 situations that can come up when we solve a quadratic function by graphing. There are 3 ways that graph could turn out. Either our parabola could intercept the x-axis, and these, by the way, are not exact parabolas. It could intersect the x-axis twice, which would mean that we have 2 real solutions, and it should say real over here, so please insert the word real. It could technically be a parabola where the only point that's on the axis is the vertex, okay, in which case there'd be 1 real solution. So this is 2 real solutions. This is an example of 1 real solution. Or it is technically possible that our parabola could not intercept the axis at all, which means it has no real solutions. Okay? So our quadratic function could have 2 real solutions, it could have 1 real solution, or it could have 0 real solutions. So, on to an actual example. Here is our first example, x squared minus 2x minus 3 equals 0. And we are then going to graph the related function x squared minus 2x minus 3. Okay, so when we do that, again, that is a process we've already discussed. The first thing we will do is identify our a value, which is in front of x squared. That would be 1. Our b value, which is negative 2. And our c value, which is also our y-intercept, of negative 3. We will then go over here and we will find our axis of symmetry. Remember, that is the equation negative b over 2a, or the opposite of b over 2a. So since b is already negative, the opposite of b would be positive 2, and a is 1. So 2 over 2 times 1, which would equal 1. So our axis of symmetry is the line x equals 1. Now again, the reason why that is important, the reason why we care about the axis of symmetry, is because that is what we need to center our table of values on when we create a table of values to graph this function. So we're going to create a table of values, and again, I'm going to include a work column. That table of values needs to contain a minimum of 5 points, because to get a proper shape for a parabola, we have to have at least 5 points. I'm just going to clean that up just a little bit. Okay, our center of our table is going to be our axis of symmetry. So our axis of symmetry goes in the 3rd row. 1 is the x value that goes in the 3rd row. The values above would be just the next 2 numbers on the number line below 1, which would be 0 and negative 1. And the bottom 2 will be the 2 numbers above 1 on the number line. What this does is it creates symmetry in the table, and it saves us some work. So we then take these x values and we plug them into f of x up here. We plug them into this for x. So we start with x squared, which would be negative 1 squared, minus 2 times x, which is negative 1, minus 3. We feed this to our calculator. That would be 1 plus 2 minus 3, which would be 0. Remember that we have symmetry between our top row and our bottom row of our table because we've centered the table on the axis of symmetry, which means that if negative 1 is paired with 0, so is 3. For the next line, we could plug it in and say 0 squared minus 2 times 0 minus 3, but we really shouldn't need to, because again, if x is 0, that is the y-intercept, which we've discussed in class, is the c value. Notice that negative 3 is what we end up getting when we plug in 0. Again, symmetry says that if 0 is paired with negative 3, so is 2. Okay? Then finally, for the axis of symmetry, we would plug in 1. 1 squared minus 2 times 1 minus 3, which would be negative 4. So we have a total of 5 points that we can graph here. We're going to go over to our graph. We're going to graph those points. Negative 1, 0. 0, negative 3. 1, negative 4. 2, negative 3. And 3, 0. Please keep in mind that if we extended that out, and someday I might show you the shortcut for graphing these, it would also pass through the point negative 2, 5 and the point 4, 5. And then by the time it intersects the next point out, it would be off the top of the graph. So we would then draw a smooth curve through those points. There's our graph. Now the reason we need the full graph is because we are going to be looking for the x-intercepts, which are here and here, because those x-intercepts are the solutions to the equation. So this graph crosses at x equals negative 1 and x equals 3. So x equals negative 1 and x equals 3 would be the solutions for this quadratic equation. Let's do another one. So here's another equation. We're supposed to solve this by graphing. So again, we're going to be graphing f of x equals x squared minus 6x plus 11. We're going to go a little bit faster this time. Again, a is in front, that's 1. B is in front of the x, that's negative 6. And c is the number, that's 11. Axis of symmetry is the line x equals negative b over 2a. That would be positive 6 over 2 times 1, or an axis of symmetry of x equals 3. We create a table of values with 5 rows. Again, we should show our work. It's not a super huge deal if you don't. Okay. We're going to plug that 3 into the middle row, which means we're going to use the numbers 1 through 5 in our table. We take these x values and plug them into f of x. So that would be x squared minus 6 times 1x plus 11, or 1 squared minus 6 times 1 plus 11. That would be 1 minus 6, which is negative 5, plus 11, which would be 6. Remember that with symmetry, if that's 6, so is the bottom. Plug in 2. 2 squared minus 6 times 2 plus 11. That would be 4. Minus 12 is negative 8, plus 11 is positive 3. Again, symmetry says that if 2 is paired with 3, so is the second to bottom row 4. And plug in 3. 3 squared minus 6 times 3 plus 11 is 9. Minus 18, which is negative 9, plus 11 is 2. Graph those points. We have 1, 6, 2, 3, 3, 2, 4, 3, and 5, 6. Smooth curve through those points. And then we look for x-intercepts. This has no x-intercepts. Doesn't cross the x-axis, which means that this particular quadratic function has no real solutions. Please be advised that it does still have solutions. You'll learn about how to deal with that in Algebra 2. So for now, instead of saying no solutions, which is not mathematically correct, we should be saying no real solutions, because the solutions to this equation are not real numbers. There will be a follow-up video with the additional two problems included in it, but that is it for the basic gist of the lesson. Thank you for your time.